Hello and welcome to my channel. In this video we are going to solve some exponential equations. Now the first question is 4 is raised to the power of 2x plus 3 is equal to 1. Now here we have to solve for x, that is we need to find out the value of x. Now in this question 4 and 1 represents the base and 2x plus 3 and 1 to the power of 1, that is this one represents the powers or exponents of the given equation. Now we have to try to get the bases, that is 4 and 1 as a common base. So let us try if we can convert this 1 in terms of base 4. Now for this we are going to make use of a law of index, which is a to the power of 0 is equal to 1. Now here a represents the base. A can be any letter or it can be any number. So for example, if we write 4 to the power of 0, then we are going to get it as 1. Which means we can convert this base 1 as 4 to the power of 0, which will give us 1 again. So let me write here. So 4 to the power of 2x plus 3, the left hand side remains the same, is equal to, now 1 is written as 4 to the power of 0 using the law of index. Now once we have got the bases on both the sides same, we can equate the powers together. So here we are going to write the power 2x plus 3 is equal to 0. Now taking plus 3 on the right hand side, we get 2x is equal to negative 3. So x will be equal to negative 3 divided by 2. That is taking 2 on the right hand side. So this is the value of x. Now let us move on to the next one. Now the second question is 3 is raised to the power of 2x minus 1 is equal to 243. Now remember that when we are solving the exponential equations, we always try to get the bases same. So here on the left hand side we have the base as 3, but on the right hand side we have it as 243. But we know that 3 raised to the power of 5 gives us 243, which means in place of 243 we can replace 3 to the power of 5. So let me write here. So we have written 3 to the power of 2x minus 1 is equal to 3 to the power of 5, which gives us 243. Now since we have got the bases same on both the sides of the equal to sign, we can easily equate the powers together. So we can write now 2x minus 1 from the left hand side is equal to 5. Now taking negative 1 on the right hand side, we get it as 2x is equal to 5. Now negative 1 becomes positive 1. So we get 2x is equal to 6, or x is equal to 6 divided by 2, which will simplify as x equal to 3. So this is the value of x in this question. Now the next question is 1 over 2 is raised to the power of x is equal to 2 is raised to the power of x plus 3. Now here we can see that on the left hand side we have the base as 1 over 2, but on the right hand side we have the base as 2. So here on the left hand side we can change this 1 over 2 as 2 over 1. So we can flip this fraction as 2 over 1. But when we do that, the sign of the power also changes. Since here the power is positive, we are going to change it as a negative power. Now here we have made use of the law of index, which is 1 over a to the power of n. As we can see, this is a fraction, is equal to, now when we take the denominator a to the numerator, the sign of the power changes, as we can see over here. Now the same law we are going to use over here. So we are going to write here 2. Now the sign of the power changes. So x becomes negative x is equal to 2 to the power of x plus 3. Now we have got the same bases, as we can see. 2 is same and 2 is same. Now we can easily equate the powers and write here negative x is equal to x plus 3. Now let us gather the like terms, that is taking negative x on the right hand side and positive 3 on the left hand side. We get here positive 3 changes to negative 3 is equal to, now this x stays the same. Now negative x becomes positive x. So we have here negative 3 is equal to x plus x gives us 2x, or the value of x is equal to negative 3 divided by 2. So this is the value of x in this case. Now the next one is 8 to the power of x minus 1 is equal to 2 to the power of x plus 2. Now you can go ahead and give it a try. Now here we have to first try to get the bases in terms of common base. So 8 we know that can be written as 2 to the power of 3. So here we are going to write in place of 8 2 to the power of 3. So we get 2 to the power of 3 raised to the power of x minus 1 is equal to 2 to the power of x plus 2. Now if we look at the left hand side, we have a power raised to another power x minus 1. Now to solve this, we are again going to make use of a law of index, which is if a is raised to a power of m and it is again raised to a power of n, then here using the law of index, the powers are going to multiply with each other. So we get the base as a, but the power becomes m times n. So using the same law, we are going to solve the left hand side. So here we have the base same 2, but 3 multiplies with x minus 1. So 3 multiplies with x first, giving us 3x, and then it multiplies with negative 1, giving us negative 3, is equal to, the right hand side remains the same. So 2x plus 2. Now here we have got the bases same now, so 2 and 2. So we can equate the powers together. So we have 3x minus 3 is equal to x plus 2. Now gathering the like terms, we are going to take this x on the left hand side and this negative 3 on the right hand side. So we get 3x. Now positive x becomes negative x is equal to, now 2 remains the same. Now negative 3 becomes positive 3. Now 3x minus 1x gives us 2x is equal to 2 plus 3 is 5. So the value of x we get here is 5 over 2. So here we get the value of x for this question as 5 over 2. Now the next question is 6 to the power of 2m times 6 to the power of negative m is equal to 6 to the power of minus 2m. Now here if we see, the bases are same. So before we can proceed, let us first solve the left hand side. Now since the bases are same and there is a multiplication involved between these two, we have to add the powers together. So here the law of index we have used is a to the power of m times a to the power of n is equal to, now the base stays the same as a, but the powers will get added up together, that is m plus n. So here we can see that the bases are same. So let us write the same base, but the powers will get added together. So 2m gets added with negative m. So this will be equal to 6 to the power of minus 2m. Now here let us solve the left hand side. 6 to the power of 2m minus 1m gives you 1m is equal to 6 to the power of minus 2m. Now once we have got the bases same, 6 and 6 on both the sides of the equal to sign, we can directly equate the powers as m is equal to minus 2m. Now let us gather the like terms, that is taking negative 2m on the left hand side, we get m plus 2m is equal to 0. So we have 3m is equal to 0, or m will be equal to 0 divided by 3, and anything dividing 0 will be 0 itself. So the value of m over here is 0. Now you can go ahead and try to solve this question. Now here we need to get 64 and 16 in terms of a common base. And we know that 4 to the power of 2 is 16 and 4 to the power of 3 is 64. So here we are going to replace 64 and 16 in terms of powers of 4 and write here 64 is written as 4 to the power of 3 times 16 is written as 4 square to the power of negative 2x is equal to, again 16 is been written as 4 square to the power of 3x minus 2. Now let us simplify this. We are going to write 4 cube as it is. Now here, using the laws of index, a power is raised to another power. So the powers will get multiplied. So we are going to write it here as 4 to the power of 2 times negative 2x gives us negative 4x is equal to, now here using the same law, the powers will get multiplied. That is 2 multiplies with 3x giving us 6x, and then 2 multiplies with negative 2 giving us negative 4. Now in the left hand side we can see that a law of index need to be used. That is, the bases are same, there is a multiplication in between. So we are going to add the powers, and right here 4 is raised to the power of 3 gets added with negative 4x. Now this will be equal to the right hand side, that is 4 to the power of 6x minus 4. Now here we have got the bases same now, so 4 and 4. So we can equate the powers and write 3 minus 4x is equal to 6x minus 4. Now let us gather the like terms. Let us take negative 4x on the right hand side and negative 4 on the left hand side. So we have 3. Now negative 4 becomes positive 4 is equal to, now 6x remains the same. Negative 4x becomes positive 4x. So here 3 plus 4 gives us 7. This is equal to 6x plus 4x gives us 10x, or the value of x is going to be equal to 7 over 10. So this is the value of x for this given question. Now for this next question, we need to find out a common base again. And here 81 and 243 can be written in terms of base 3. That is 3 to the power of 4 gives us 81. And 3 to the power of 5, we have already seen that it gives us 243. So let us write 81 and 243 in terms of base 3. So here 81 we have written as 3 to the power of 4 is raised to the power of 3n plus 2 divided by, in place of 243 we have written 3 to the power of 5 raised to the power of negative n is equal to 3 to the power of 4. Now let us simplify this fraction. That is, by multiplying the powers we get the numerator as 3 to the power of 4 multiplies with 3n giving us 12n plus, now 4 multiplies with 2 giving us 8 divided by, now 3 to the power of 5 multiplies with negative n giving us negative 5n. This will be equal to 3 to the power of 4. Now here, to solve the left hand side, we are going to make use of another law of index, which is a to the power of m divided by a to the power of n will be equal to a to the power of m minus n. So here, if the bases are same, a, and there is division involved, the powers need to be subtracted. So here we can see that the bases are same on the left hand side, 3 and 3. So we are going to subtract the powers and write here 3 to the power of 12n plus 8 minus of minus 5n. So we are subtracting the denominator power with the numerator power is equal to 3 to the power of 4. Now the bases are same on both the sides of the equal to sign. So here we are going to simplify the powers on the left hand side and equate it with the power on the right hand side. So we get here 12n plus 8 and minus of minus gives us plus 5n is equal to 4. Now let us add the like terms. 12n and 5n are like terms and that gives us 17n. And let us take plus 8 on the right hand side. So we get 4 minus 8. So we get 17n is equal to 4 minus 8 gives us negative 4, or the value of n is equal to negative 4 over 17. So this is the value of n for the given equation. Now moving on to the last question. You can go ahead and give it a try. Now here, let us try to get 16 and 4 as a common base of 2. Now 16, we know that we can write it as 2 to the power of 4, which gives us 16. And let us raise it to the power of 2a minus 3 as it is given in the question. Times. Now 4 can be written as 2 raised to the power of 2. And here let us raise it to the power of negative 2a is equal to, now the right hand side stays the same. Now here again, making use of laws of indices, we can multiply the powers. So here we have 2. Now 4 multiplies with 2a giving us 8a, and 4 multiplies with negative 3 giving us negative 12 times 2 to the power of, the powers will get multiplied. So 2 multiplied with negative 2a gives us negative 4a is equal to 2 to the power of 4. Now again, here using the laws of indices, the bases are same and there is multiplication in between these two terms. So we are going to add the powers and write here 2 to the power of 8a minus 12 plus minus 4a is equal to 2 to the power of 4. Now here the bases have become same, so we can equate the powers now, and here we are going to write 8a minus 12 minus 4a is equal to 4. Now let us gather the like terms. 8a minus 4a gives us positive 4a is equal to, let us take negative 12 on the right hand side, so we get 4, negative 12 becomes positive 12, or 4a is equal to 4 plus 12 gives us 16. So a will be equal to 16 divided by 4. So here we get the value of a as 4. So here in this equation the value of a was 4. I hope you have understood all the steps and liked the video. And if you found this video useful, then you can check out this playlist where you will find more examples of this kind. And if you are liking my videos, like, share and subscribe to my channel, and thank you for watching.